Today, in this video lecture, we will see Chapter 4 Strain, Energy and Impact and Numerical 3. This Numerical 3 is on Impact Load. Our previous two numericals are on Suddenly Applied Load and this numerical is on Impact Load. Now the difference is formula for impact load. Stress formula for impact load is different and suddenly applied load stress formula is different. So this is main difference of this type of numerical. So we will first read this numerical. Determine the instantaneous stress and deformation of rod. That means our problem statement is instantaneous stress and deformation. Deformation, that means delta L, and instantaneous stress is maximum stress. And length of rod is 1 meter. Length of rod, that means this length. This L is 1 meter and this is rod. And diameter 6 mm. So they have given us diameter of that length 1 mm rod. That means we get information like this rod is circular rod. So circular rod, or you may call it member. If a mass of 50 kg falls through height of 10 centimeter, so this is something mass 50 kg and falls through height of 10 centimeter. That means this height is 10 centimeter. And the rod is freely suspended and fixed at top. See, this circular rod of length 1 meter is fixed at top. And assume modulus of elasticity as 210 GPa. So this is our numerical. Understand first numerical. Understanding numerical is very important step than solving numerical. So first write given data. And sorry for voice, that means no, sorry for noise. So given data is this rod, length of that rod denoted as capital L is equal to 1 meter. 1 meter, that means 1000 mm. Diameter of that member is denoted as small d, 6 mm, mass 50 kg, and falls through a height of 10 centimeter. Height denoted as small h, 10 centimeter. That means 100 mm. And this movable load is strikes to the bottom of this rod. Okay, this is collar and this red is this is rod. And they called us this is the bottom of rod. And this movable load strikes to the bottom of this rod. And the rod is freely suspended and fixed at top. Okay. E, modulus of elasticity 210 GPa. GPa means gigapascal, and C, we write our units are in mm, and gigapascal, that means 210 into 10 raised to 3 megapascal. And you all know megapascal is nothing but the 1 megapascal is equal to 1 Newton per mm square. And our problem statement is to find stress and deformation. So first of all, don't operate this type of numericals. These are very straightforward numericals. Only understanding is important. So instantaneous stress formula is, or for impact load, so right here for impact load, this impact word, see here, they have given us word impact. Determine the instantaneous stress and deformation of a rod 1 meter 50 kg falls load strikes at the bottom. This is impact type of load. Impact stress formula is sigma is equal to load upon area plus under root of load upon area square plus 2 modulus of elasticity multiply by load and multiply by height. Height is this small h upon area and length, and this area is this member area. This member area. So see this formula. W load, we don't have this W. See this movable load W, we have only M mass, and mass is in kg. Mass is 50 kg. So we don't know mass. What we don't know, I circle it in red color. So this W I don't know. Area also they don't give us the numerical, so area also I don't know. W this H, and what I know, I circle it in this yellow color. I know this, sorry, this yellow is not visible. This color, this E is I know, this H is I know, this L also I know. This L is nothing but this length of that member. So this red color data I don't know. So for getting this red color data, W, and W is what? Load is nothing but the mass into acceleration due to gravity. And I know mass they have given us in numerical. Mass is 50 kg and acceleration due to gravity is, we all know, 9.81. So mass is 50 and acceleration due to gravity is 9.81. So 50 multiplied by 9.81 is 490.5 Newton. And area, and I told you in our derivation of this impact stress, area is this member area, and we all know diameter of this member is 6 mm. So, and this they have given us diameter, that means this is circular member, and circular cross sectional area we all know 5 by 4 into d raised to 2, and d we know d is 6. 5 by 4 into 6 square is nothing but the 28.27 mm square. So see, now we have W also and A also. So our work is only put data in this formula and get this stress. sigma is equal to W is 490.5 area is 28.27 plus this same term square 490.5 in area 28.27 square plus 2 E is this 210 MPa. Sorry, this not only 210 MPa, 210 GPa, that means 210 into 10 raised to 3 MPa. This multiplication factor is important for conversion from GPa to MPa. And H is this 10 centimeter. Given data 10 centimeter. Centimeter, that means 100 mm, because we put all values in mm. So 100 mm divided by A into L. A is 28.27 and L is 100. L is not 100, L is 1 meter, that means 1000 mm. So this sigma is 2EH, and we write here this E, this H, but we don't write this W. This W is 490.5 Newton. Right here, like. So 490.5 upon 28.7 plus under root of 490.5 upon 28.7 square plus 2 into 210 into 10 raised to 3 into 100 into 490.5 upon 28.27 into 1000. So the stress comes 871.17 Newton per mm square. Always write these units are in exam. These units are very important. Now our first problem statement is complete. We find out this. Now our next target is to find delta L. And delta L, that means deformation. Deformation is sigma L upon E. Sigma is 871.17. E is L is 1000. L is given data and E is also given data. 210 into E is 210 into 10 raised to 3. So this delta L is 4.15 mm. This delta L value is always minimum. Change in length is always minimum value and unit is mm. And this stress is for impact load, it is greater value 871.17 Newton per mm square. And only by using this impact stress formula and by using this deformation formula, you will get 8 marks in exam. And if you have any doubt, Feel free to reach me. My email ID is devrekaran86@gmail.com. Thank you very much.